stretching that happens due to a gravitational wave is extremely small. It's 10 to the minus 22 meter per meter, and that's like the distance from Earth to the Sun is 10 to the 11 meters. So imagine you have a ruler from the Earth to the Sun. Then you need to measure something in the scale order of 10 to the minus 11 meters, which would be 1/10 the diameter of an atom. My research field for my thesis is essentially instrumentation for gravitational wave detectors. You can imagine that vibrations like from the ground and other noise sources very quickly affect your measurement apparatus. There are currently gravitational wave detectors. Gravitational waves have been detected with these detectors, but we're now at the startup point essentially of the development for the next generation of gravitational wave detectors. And while these detectors should only be like a factor 10 more sensitive in a broad part of their sensitivity band, actually at the low frequencies, these detectors need to be about a factor 1 million more sensitive. For my thesis, I I did a various amount of things to essentially help the low frequency performance of detectors. I focused on all the noise sources that add up to one of those individual suspensions. But very quickly you find out the performance of a local suspension has effect on the entire interferometer. The work I've been doing has been both on hardware, from designing hardware to assembling and commissioning to modeling hardware. My personal joy mostly goes out to the modeling of systems. As a mechanical engineer, I've done a lot with respect to designing or assembling or those kind of things. If you have an actuator at your system, the more it can actuate, the stronger its force, the stronger its actuation noise. It can be important to decide to use the passive filtering of the system that's used to isolate vibrations from the ground, to also isolate vibrations from your large actuation steps. So if you take perhaps a tower here, then if you want to actuate on this little ball, maybe you want to move things for large displacements at the base, and then the closer you get to the mirror, have essentially less actuation to have less actuation noise coupling in.